My dear students, in the previous video, I have defined the continuous random variable and the probability density function for a continuous random variable. By the definition of the continuous random variable and the probability density function, we have solved some problems also. Now in this video, I am going to define distribution function or cumulative distribution function of a continuous random variable. So distribution function for a discrete random variable you have seen already. In this case, the distribution function or cumulative distribution function of a continuous random variable we are going to see in this video. So the distribution function or continuous distribution function capital F of x, the distribution function or continuous cumulative distribution function is always defined by capital F of x, whether the random variable is discrete or continuous. The random variable is, if it is the random variable is discrete random variable or continuous random variable, the distribution function or cumulative distribution function is always defined by capital F of x only. Notation is capital F of x for both the random variables. So the distribution function or cumulative distribution function capital F of x of a continuous random variable x with its probability density function. This is we have defined already. Probability density function, that is integral minus infinity to plus infinity, f of x dx is 1. See, this is the probability density function is defined by probability of x less than or equal to x, that is capital F of x equal to integral minus infinity to x. See, integral minus infinity to plus infinity f of x dx is equal to 1. If the probability density function is small f of x, its integral minus infinity to plus infinity, the summation of all the probabilities is 1. But this is the property of probability density function. But in the case of capital F of x, that is probability of distribution function is in this from minus infinity to, we should not go up to infinity, we stop at the stage x, minus infinity to x, the stage x where the x is defined. Minus infinity to dx, f of x dx is called capital F. That's why we are defined here. The distribution function or cumulative distribution function capital F of x of a continuous random variable x with its probability density function small f of x is defined by p of probability of x less than or equal to x or capital F of x is equal to integral minus infinity to x. Where should we stop? Where that function is to be defined. Probability of x less than or equal to x is minus infinity to x f of x dx. This is called probability density distribution function or cumulative distribution function. And also some properties of cumulative distribution function is probability of x less than or equal to x is integral minus infinity to x f of x dx. Whereas probability of a less than or equal to x f of less than or equal to b. In this interval, probability of a less than or equal to x less than or equal to b, the distribution function for this interval is capital F of b minus capital F of a. Capital F of b minus capital F of a gives you the probability of x lies between a and b. And also probability of x in less than or equal to x is f of x, whereas probability of x greater than or equal to x is 1 minus probability of x less than x. That is 1 minus p of x less than x is f of x. So probability of x greater than or equal to x is 1 minus capital F of x. And lies between a and b is f of b minus f of a. These are the two properties for cumulative distribution function. Okay? Now let us solve one problem using this cumulative distribution function. See, the probability density, this is in the exercise 11.3, fourth problem. The probability density function small f of x is given by k into e power minus x by 3 for x greater than 0, 0 for x less than or equal to 0. For x greater than 0, function existed k e power minus x by 3. For x is less than or equal to 0, function is 0. Probability density function is 0. K is any constant. Then we have to find the first problem is first subdivision, then find the value of k. Second one is find the distribution function capital F of x. Third, probability of x less than 3. Fourth, the probability of x is less than or equal to 4. And the fifth one, probability of 5 less than or equal to x. These are the 5 subdivisions in this problem. So given f of x is given by k into e power minus x by 3 for x greater than or equal to 0. First to find the value of k, to find k, we know that since f of x is a probability density function, minus infinity to plus infinity, f of x dx is 1. You know, since the small f of x is a probability density function, its integral value from minus infinity to plus infinity, f of x is 1. But the function existed only from 0 to infinity. Minus infinity to 0, the function is 0. Less than 0, see, this is minus infinity, this is 0 and this is infinity consider. Greater than 0 function existed, less than or equal to 0 function is 0. Here k into e power minus x by 3. Here the function is 0. See, for the function x greater than 0 function existed. Therefore, minus infinity to plus infinity f of x dx is 1. But this problem minus infinity to 0 function is 0. So you consider only from 0 to infinity. See, minus infinity to 0 function is 0. Plus integral 0 to infinity function exists. From integral 0 to infinity f of x is k into e power minus x by 3 dx equal to 1. This is 0, we need not worry about the first integral. You can take that k outside. Integral 0 to infinity, 0 to infinity e power minus x by 3 dx equal to 1. So k into integral value of e power minus x by 3, you know, minus e power minus x by 3 by 1 by 3. That is the integral value from 0 to infinity. It is equal to 1 given. So the integral value is integral k into e power minus x by 3. Integral value is e minus e power minus x by 3 by x by 3 integral is 1 by 3. But derivative, the constant 1 by 3 will get in the denominator, which is equal to 1 given. So this 3 taken out, we will get 3k. You can take minus also outside, minus 3k e power minus x by 3 from 0 to infinity equal to 1. Minus 3k, first we give upper limit. For x equal to infinity, e power minus infinity. Okay. Minus lower limit, e power 0 equal to 1. We know that minus 3k into e power minus infinity, you know, e power minus infinity is 0. Minus e power 0 is 1 equal to 1. You know the entire value of e power minus infinity is 1 by e power infinity, that is 0. And e power 0 is 1. Multiplying you will get minus plus 3k equal to 1. K equal to 1 by 3. That's all about the value of k. Second one, they want you to find out the distribution function capital of x. See, distribution function capital F of x is equal to, instead of k, you write 1 by 3 e power minus x by 3 for x greater than 0. So instead of k, after finding the value of k, you substitute the value of k. K is 1 by 3. That is the distribution function capital F of x is e power, this is we have to find out this value, you have to find it within 1 minute. Here also distribution function p of x less than or equal to x is capital F of x, that is equal to integral minus infinity to x, that density function f of x dx. This is our definition. So from this, listen. probability of x less than or equal to x, capital F of x is integral minus infinity to 0, function 0, and minus infinity to 0, 0 to infinity only you will get the function. So integral minus infinity to 0 to infinity only, minus infinity to 0, function 0, minus 0 to infinity, that is 0 to x greater than 0, f of x dx, that is equal to, this is integral 0 to x, f of x is integral 0 to x, f of x is 1 by 3 into x, k e power minus x by 3 into dx. So this is equal to 1 by 3 into integral e power minus x by 3 is minus e power minus x by 3 by 1 by 3 from 0 to x. So that is equal to 1 by 3, 1 by 3 get cancelled, you will get, you can take minus outside, 1 by 3, 1 by 3 cancel, you will get e power minus x by 3 from 0 to x. That is equal to minus instead of x, you substitute x, you get e power minus x by 3 minus e power 0, e power 0 is 1. Therefore this is, if you taking minus inside, e minus e power minus x by 3 minus into minus plus, e power 0 is 1. Therefore 1 minus e power x by 3, the f of x is, see, f of x for, listen, we derived that after finding the value of k, the distribution function capital F of x equal to 1 minus e power minus x by 3 for x greater than 0, otherwise function 0, 0 for x less than or equal to 0. This is our distribution function. Second answer. Second question, distribution function, our cumulative distribution function, capital F of x is 1 minus e power minus x by 3 for x greater than 0, 0 for x less than or equal to 0, because less than 0 function does not exist. Then third one, now we will go to the third subdivision of the problem. What is third one? Probability of x less than 3. This is nothing but f of 3. Okay. Probability of x less than 3 is f of 3. F of 3 is 1 minus e power minus 3 by 3. X equal to 3, you have to substitute. That is 1 minus e power 3 by 3 is 1, e power minus 1. So, p of x less than 3 is 1 minus e power minus 1. That is third subdivision. Fourth one, probability of x less than or equal to 4. This is equal to f of 4. This is equal to f of 4 is 1 minus e power minus 4 by 3. This is fourth subdivision. F of 4 is 1 minus e power minus 4 by 3. Okay? And fifth only one we want, the final subdivision, p of 5 less than or equal to x. So that is this one. Fifth one is probability of 5 greater than x. 5 less than or equal to x. Fifth one is 5 greater than x. Problem is 5 greater than or equal to x. Given. So this is 5 greater than or equal to x. Fifth one. This is nothing but 1 minus p of 5 less than x. 1 minus x less than 5. That's the definition. If p of x greater than or equal to capital X is 1 minus p of x less than x. That is the concept. So p of 5 greater than or equal to x is 1 minus p of x less than 5. That's equal to 1 minus p of x less than 5 is f of 5. That's equal to 1 minus f of 5 is 1 minus e power minus 5 by 3. 1 minus e power minus 5 by 3. So 1 minus 1 0 minus minus plus e power minus 5 by 3. This is p of 5 greater than or equal to x. So that's all about this problem. I will stop this video here and we will continue the remaining problem in the next video. Thank you.